Hi, I'm Ben. I'm graduate student at Princeton, and for the what I'm going to talk about is it's just going to be like a high-level overview of some of the different parts of my thesis. Um, Kind of focusing on minimal surfaces in the setting of negative curvature in 3 dimensions, mostly, or actually entirely for the talk. Yeah, and so in 2 dimensions, so for a genus bigger than one surface, as you probably know, there's this great fact that you kind of have all these different hyperbolic metrics, like a 6G minus 6 dimensional Teichmüller space of them. But this fails in, dimension above 2. If you have a closed hyperbolic three-manifold, for example, then the hyperbolic metric is unique up to isometry. So if you want to form hyperbolic metric, you have to either relax, to form a hyperbolic three-manifold, you have to either relax the closed condition, like look at infinite volume ones, or relax the constant curvature condition. And so we're going to kind of look at both of those, and kind of from the perspective of like what minimal surfaces that they contain. And so I'm going to kind of think about questions like how are like hyperbolic, how is the hyperbolic metric different and similar to the other negatively curved metrics on closed hyperbolic three-manifold, kind of from the vantage point of like what the minimal surfaces look like. And in the final part of the talk, I'm going to kind of change directions a little bit and talk about some kind of results relating scalar curvature and an area of certain surfaces when the underlying topology is that of a closed hyperbolic three-manifold. So AMB topology is that of a closed hyperbolic three-manifold. And here are kind of questions about like the uniqueness of the hyperbolic metric. Like it's unique within, all the metrics with constant curvature -1, but it might not be the unique conformally flat constant scalar curvature metric, for example. And so kind of those sorts of considerations will end up being important in answering in these results about scalar curvature and area. So yeah, I hope you enjoy my talk.